Hi everyone, let's walk through 3 examples of how to express a rectangular equation, that's in terms of x and y, in its polar equivalent form that will be in terms of r and theta. As we go through these, we'll also be considering what the graphs of these look like. So let's start with the equation y equals -2. We all know this to be a graph of a horizontal line passing through the y-axis at the point 0, -2. So we know that's what the graph looks like, but let's explore what the polar equivalent form would be. And as we do this, we're going to make use of those formulas that we looked at earlier in this lesson. You'll recall that y is equivalent to r sine theta. So in place of y, we're going to put r sine theta. And in polar equations, they typically are in terms of r with respect to theta. So the object here would be to get r by itself. So to do that in this case, we're simply going to divide both sides by sine of theta. So we can leave this as r equals -2 over sine of theta, or we can rewrite it as -2 cosecant theta. So that would be the polar equivalent of the rectangular equation y equals -2. Now let's start talking a little bit about how you graph in polar form on your graphing calculators, and you'll see that even though we're going to graph a polar equation, it still comes out as a horizontal line like we know the graph should look. So on your graphing calculators, let's walk through first how to put your calculator in polar mode. You're going to hit the mode button, and then down on the 5th line, same place we went when we were dealing with parametric equations, but you'll notice right next to that it says polar. So just arrow over to there, then hit enter on top of that. Now when you hit your y equals button, you'll notice you have equations that are in terms of r. So we're simply going to type in that which we had. So let's leave it in terms of sine. So we'll do -2 divided by sine. And now when you hit your x button, you'll notice you get a theta. We can still do zoom trig, since it is a trig equation, and lo and behold, it is still the graph of a horizontal line. So let's go look at another one. The next one we're going to explore is x squared plus y squared equals 25. Again, we all know this to be the graph of a circle centered at the origin with radius 5. We're going to again use those formulas we saw earlier. We know that x squared plus y squared is equivalent to r squared. So we're going to make that substitution on the left. Solving then for r, we get r equals 5. And if you think about what we knew when we were plotting points in the polar plane, if you imagine plotting points so that the r value was always 5, you would be going 5 units out from the pole all the way around the circle, thus producing a circle as the graph. But let's go take a look at it on the graphing calculator, and you'll see that we get the same thing. So going back to r equals, let's clear that out and simply put 5. Let's do zoom standard for this because I want to make sure we can see the whole thing. So let's do zoom 6. Now it doesn't quite look like a circle, but if you take a look at it, you'll notice that all the points, if you take a look at the quote-unquote y-axis, would be 5 units up, 5 units down. It's also 5 to the left and right. If you do zoom square, actually, zoom 5, now it looks more like a circle. So again, no matter what form you're in, either rectangular or polar, the graph, the picture, always looks the same. So let's take a look at one last example, and this is a great example of one that we cannot graph as a rectangular equation very easily. At least we cannot do it in our calculator. So the last one we're going to look at is the equation 2x squared plus 2y squared minus 5y equals 0. If we had really wanted to try to graph this in our calculators in rectangular mode, remember we'd have to get y by itself, which we really cannot easily do. So this is a great example of an equation that, while it's not too easy to graph it in rectangular mode, put it in polar mode, and then we can very easily see what it looks like. This one you have to be a little creative because remember we want to use those formulas that we knew before. If you take a look at the first 2 terms though, that has that x squared plus y squared in it. So what we're going to do is factor out a 2 there. And now we can start making substitutions because we know x squared plus y squared is equivalent to r squared. In place of y, we can put r sine of theta. Now we have at least an equation with r's and thetas as we need it to. From here, we're going to factor out an r. And if you think of the zero product property from algebra, that still applies, even in polar mode. We would have that r equals 0, and then 2r minus 5 sine of theta equals 0. R equals 0 is really an extraneous solution. If you think about what that would look like on the polar plane, that's simply a point at the pole, so that's not really an answer. Over here, though, we can easily solve this equation for r, obtaining r equals 5 sine of theta over 2. That is something we can very easily graph in our graphing calculator. So let's go do that, and now we'll actually know what this graph is supposed to look like. So returning to r equals, let's clear out that one, and we can do it as 5 halves. A lot of different ways. Obviously, you can type this in. You could even do a decimal 2.5 if you wanted to. Sine of theta. I should make mention of the fact, and I'm sure you are, but just to double check, you should be in radian mode for these, okay? But I have a hunch you're already there. But just to make mention of that fact. So let's try to do zoom trig first and see what that looks like. We can always play with the graph from there. Looks like an oval. We could do a few different, let's try zoom 6. Yeah, it still looks like an oval of some sort. Zoom square, and that's what the graph looks like. So again, something that in a rectangular mode, not too easy to graph, but in a way it makes sense because it is that one form we know of a circle with the x squared plus the y squared in it, also has that minus 5y in it. So it makes sense that it's a circle of some manner or shape. So as we continue in our next video to look at going the other way from polar form to rectangular form, we'll explore the graphs a little bit more. But hopefully this gives you a sense of how you can use your calculator, and we will be doing a good bit of this to graph polar equations moving forward on our graphing calculator.